Hello, this is Mr. Henry, and welcome to lesson 13.3. In this lesson, we are talking about combinations. Now, combinations are very similar to permutations, or I should say the formula is similar. What's going to be different about combinations from permutations is in permutations, the order made a difference. You picked first and second place. Combinations, the order does not matter. You're just picking two people. It doesn't matter which one you pick first and which one you pick second. So here we have our essential question says, how do I find the probability using combinations? And we have a get the goof down here. It says John has 10 different pairs of sneakers. He wears a different pair every day for 3 days. How many different ways could he wear his shoes? Okay. Well, the get the goof down here says 10 pick 3. I don't agree with that because it doesn't say you're only picking 3 pairs of shoes. It doesn't say how many shoes could he wear for 3 days. It just says he wears his shoes for 3 days each. Well, okay. So in my mind, the problem would not be this. The problem would be something like 10 pick 10 or 10 permute 10. So 10 pairs of sneakers, and how many ways could he wear his shoes? So 10 permute 10 would be that 10 factorial. So 10 times 9 times 8 times 7, 6, 5, 4, 3, 2, 1. And I have no clue what that is. So let's see. 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 5,637,600. 5,637,600 ways he could wear his shoes. That's not a decimal point, that's just a dot. There. That's how many ways he could wear his shoes. The 3 days seems like his extra information trying to trick you up. And it did for that get the goof. Now we've got one vocab word here. It is a combination, and a combination is an arrangement of objects in which the order is not important. So again, you're not picking first, second, third place. You're just picking 3 objects from a bag or 3 students from a classroom to run an errand. You're not picking students to get prizes or anything like that. Now, the formula here is similar to a permutation. If you remember that formula for permutation, so if I had like 3 permute 2, whatever, it was 3 factorial over 3 minus 2 factorial. What's different about the combination, if I do that same thing, 3 choose 2 now, well, it's still going to be 3 factorial over 3 minus 2 factorial with the addition of this additional times by 2 factorial, timesing by this second number again. So this would be 3 times 2 times 1 over, this is 1 factorial, which is just equal to 1, times 2 times 1, and this cancels, and this cancels, and that whole thing would be equal to 3. Okay. So hopefully you're seeing the difference. The difference is you have this additional times by that second number on the bottom. The rest of the formula is the same. This is different here. So let's see what we're talking about. In example 8 here, it says, count the combinations of 2 letters from the list of A, B, C, D. So it's just going to have us pick 2 letters, and we want to know how many different combinations are there. Well, if you think about it, we got A, B, A, C, A, D. There's 3 different combinations. Now, you could not pick B, A, because as far as a combination is concerned, this is the same thing. Because the order doesn't matter. You've picked an A and a B. It does not matter you pick one before the other. So those are the same thing. So that does not count as a different combination. In fact, I'm going to even erase it and put it up again. So it was A, B. Other combination. You got B, C. Don't have those 2 letters yet. B, D. and CD. Those are actually all of the combinations using those 4 letters, picking 2 of them, or choosing 2 of them. Now, let's check out that formula. So it's 4 choosing 2. So you're going to do 4 factorial over 4 minus 2 factorial. That so far is the permutation, times by another 2 factorial. This guy factorial again. So this thing would simplify, and I know I'm kind of slanty here. I'm sorry about that. It's been unslanty a little bit. Something like that. So this would be equal to 4 times 3 times 2 times 1 over this 4 minus 2 is just 2 factorial. So a 2 factorial times by another 2 factorial. Cancel out common factors. Boom, boom. And you've got 12 over 2. 4 times 3 is 12. 2 times 1 is 2. Simplify 6. So there are 6 combinations of those 2, we're picking 2 letters from that set of 4. Remember, AB and BA are the same. AC and CA are the same. So that's why there's not a whole bunch more. If you wanted all the different ways they could be arranged where A, B, and BA are different, that's a permutation. Okay? Letter B. List all the combinations of 3 letters, A, B, C, D, E. Well, first thing I want to do is I want to find out how many there are. So before I go through and I start listing, I just want to make sure I get them all. So if I do the formula, there's 5, and I'm choosing 3 of them. So that would be 5 factorial over 5 minus 3 factorial. That's the permutation. And the combination is you add an additional 3 factorial at the bottom. Or not add, you're multiplying by another 3 factorial on the bottom. So that gives you 5 times 4 times 3 times 2 times 1 over, that's 2 factorial, so 2 times 1, 3 factorial. 3 times 2 times 1. So cancel, cancel, cancel. You're left with 20 over 2, which is 10. So there should be 10 different ways to pick 3 letters or choose 3 letters out of those 5. So we've got an A, B, C, A, B, D, A, B, E. So those are all the ways just starting with A, B. And now we've got A, C, D, A, C, E. So the ways that start with A and C. And A, D, E. I think those are all the possible ways that have A in the front. So I'm just kind of doing this kind of logically. And you'll notice so far, all of my different combinations have all 3 letters are not repeated in just a different order. So I've got a B, C, D, B, C, E, B, D, E, and finally C, D, E. So if you notice, each one of my combinations here, I do not have the same 3 letters repeated, just in a different order. In every different combination, I have 3 different letters, so to speak. So you'll never see these 3 letters repeated someplace else just in a different order. There's no A, B, E anywhere else. Okay, so there's 10 combinations. Okay, let's continue on. So if you could please, I'd like you to pause the video, try this problem on your own. When you're ready to continue, hit play, and then we'll go through it together. Alright, so we've got 5 choices, and we're choosing 2 of them. So we've got 5 factorial over 5 minus 2 factorial, that's the permutation part, and then multiplied by additional 2 factorial. Okay, so let's see. That would give us 5 times 4 times 3 times 2 times 1 over 3 factorial times 2 factorial. Okay, so 3, 2, 1 times 2, 1. So we have a 2 and a 1 in common. We also have a 3 in common, which gives us 20, 5 times 4, 1 times 2, simplify, 10. Okay, so let's see. We've got A, B, A, C, A, D, A, E. Those are all the possible combinations that have an A in it. We've also got a B, C, B, D, B, E. Now those are all combined with that one. These three and that one are all the possible combinations that have a B in it. We've got C, D, and C, E. So this and that one are all the 4 ways you could have a C in it. And finally, D, E. So 1, 2, 3, 4. These are all the possible ways of having a D. Now, I started thinking about another way to do this instead of using this formula, because I really don't like the formula. It's really bugging me. So if I was thinking, how can I do this using something that I'm familiar with? So if I do that 5, choose 2. Now think about this in terms of like the permutation. We did 2 blanks, 5 times 4. Remember that? If we were doing a permutation? The way I found you could do this is if you do that, 5 times 4, and then just put this other 2 factorial down below. So 5 times 4 over 2 times 1. Look at this. 5 times 4 over 2 times 1. Boom. On this page, 5 choose 3 gives you 3 blanks. So 5 times 4 times 3 over 3 times 2 times 1. This is 3 factorial. Well, 3 and 3 can still cancel. 5 times 4 over 2 times 1. 5 times 4, 2 times 1. Boom. 4 choose 2 gives you 4 times 3 over 2 factorial, which is 4 times 3 over 2 times 1. 4 times 3 over 2 times 1. Boom. So just another way to think about it. I'm not saying you have to do the formula. I'm not saying you have to do it that way. In fact, I don't even know if I like this way yet. I'm just showing you something else I thought about that does work. A different way to think about it. If you really liked the permutation way and you're familiar with that, that's another way it could be done. Or you could use the formula way. There's nothing wrong with the formula. It involves a lot of canceling stuff out. It usually takes a little bit more space on the paper, but I'm not saying it's a hard method. Okay? Let's jump down to example 2. Now, in example 2, we're not listing them anymore. So they just want to know how many different possible combinations are there. So it says you go to Subway to order a smoked turkey sandwich. You want to decide how many combinations are for toppings, or how many combinations there are for toppings if you have 7 options to choose from. So kind of thing that I do naturally if I go into a place and go, well, I wonder how many different ways I could pick these different toppings. Well, here you're picking 2 toppings. And again, what makes this a combination is the order they put the stuff on your sandwich is not important. It doesn't matter if they put lettuce and then tomato or tomato then lettuce. They're just putting the stuff on the sandwich and you eat it. So you're doing 7 to total, but you're choosing 2 of them. So total, you're choosing 2. Now, I'll do the formula way, why not? So it's 7 factorial over 7 minus 2 factorial. That's the permutation. What makes the combination is another 2 factorial down below. So that would be 7 times 6 times 5 times 4 times 3 times 2 times 1 over, this is 5 factorial, 5, 4, 3, 2, 1, and another 2 factorial, 2, 1. So 2's and 1's cancel. 3, 4, 5, 3, 4, 5. So you're left with a 42, that's 7 times 6 is 42, and 2 times 1 is 2, and simplified you get 21. So there's basically 21 different ways you could get 2 different toppings put onto your sandwich if you have 7 choices. There, 21 combinations. Letter B. Same scenario. You want to put this stuff on your sandwich, but now you're thinking, well, what happens if you get 4 toppings instead of just 2? How many ways could that be put on your sandwich? Okay, well, there's 7, and you're choosing 4. So 7 factorial over 7 minus 4 factorial. That's the permutation. And an additional 4 factorial on the bottom. So 7, 6, 5, 4, 3, 2, 1, dot, 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 over, that's 3 factorial, so 3, 2, 1, times by 4 factorial, 4, 3, 2, 1, cancel, 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 cancel. Nothing else cancels, so that gives us 7 times 5, or 7 times 6 times 5 is 210. 3 times 2 times 1 is 6, and that is 35. So when we simplified, we canceled out some stuff here, and we got 210 over 6, and simplified the fraction, and got 35 combinations. Last problem here of this type is one for you. So it says, what if you were allowed 3 choices, but Subway offered 10 different options? So now they have 10 options, but you're picking 3. How many different combinations could you get? Could you do this problem on your own right now? Pause the video. When you're ready to continue, hit play, and we'll go through it together. Okay, so let's see. 10 total, you're choosing 3. So that would be 10 factorial over 10 minus 3 factorial, that's the permutation, times by another 3 factorial. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, multiplied together, that's 10 factorial, over 10 minus 3 is 7, so 7 factorial is 7, 6, 5, 4, 3, 2, 1. And 3 factorial is 3, 2, 1. And if you cancel some stuff out, so look at this. 7 through 1, 7 through 1. Boom, gone. So you've got 10 times 9 times 8 over a 3, 2, 1, which is 10 times 9 times 8 is 720. And 3, 2, 1 is 6, and you simplify, you get 120. So there's 120 combinations of ways you could put your sandwich together if you had 10 options and you put 3 of them on there. Okay. Now, example 3. Finding probability using combinations. It says a yearbook editor has selected 14 pictures for the yearbook. The pictures are placed at random. There's room for 2 photos at the top of the page. What is the probability, keyword, what is the probability of your photo and your best friend's photo are together at the top of the page? It doesn't say you come first and your best friend comes second. If it did, that would be a permutation. Combination just says, well, you and your friend are together at the top of the page. So we're talking about 14 and you're choosing 2 of them. That's essentially what we're doing. So that would be, let's see, 14 factorial over 14 14 minus 2 factorial times by another 2 factorial gives you, well, 14 times 2 is 12. So if you think about this, I'm going to try to avoid writing out everything. We got 14 times 13 times 12 factorial, right? So 12, 11, 10, 9, 8, 7, 7. Well, down the bottom, we've got a 12 factorial times by a 2 factorial. Well, this whole 12 factorial and that whole 12 factorial will cancel each other out. So what you're left with is much smaller. You've got just 14 times 13, and 2 factorial is 2 times 1, and that simplifies to be 91. So if you're kind of thinking ahead, instead of just brute force writing out everything and going through and canceling out everything, if you think ahead a little bit, you can actually save yourself quite a bit of writing. The next question you ask yourself is, are you done? Is 91 the probability that your best friend's photo and your photo are at the top of the page together? The answer is no. That's not probability. That's how many ways all those 14 photos can be at the top of the page, but the probability that you and your friend are together, well, there's 1 out of that 91. So those are all the combinations. One way have you and your friend together. Okay? Example B. Same scenario, 14 pictures, room for 2 photos at the top of the page. Now it says, well, I guess it's not the same scenario, because now it says if there are 20 photos, so blah, 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 blah. If there are 20 photos, what is the probability that your photo and your best friend's photo are at the top of the page together? So same idea, but instead of 14, now you're doing 20. So 20 choosing 2. So it'd be 20 factorial over 20 minus 2 factorial. That's the permutation. And an additional 2 factorial. So again, I'm not going to write out the whole thing because I'm going to work smart instead of work hard. So 20 factorial is 20 times 19 times 18 times 17. Well, it's going to be 18 factorial. 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Over 18 factorial times by a 2 factorial. Well, my 18 factorials right here are going to cancel. Boom. What's left? Well, 20 times a 19 over a 2 times a 1, giving you 380 over 2. That's 190 total. So there's 190 total ways. If there's 20 pictures, 190 ways you can pick 2 of them for the top of the page. Only one of them will have you and your best friend together. So the probability of you and your best friend being at the top of the page together is 1 out of 190. Letter C. This is one for you to do. It says your teacher randomly chooses 3 out of 18 students to give an impromptu debate on freedom of the press in a middle school newsletter. What is the probability the teacher chooses you, your best friend, and the class clown? Go ahead, pause the video, try this problem on your own right now. When you're ready to continue, hit play, and we'll go through the problem together. Okay, so there are 18 students, and you're choosing, choose should be bigger, and you're choosing 3 of them. So that's 18 factorial over 18 minus 3 factorial times by another 3 factorial. All right, so that's 18. Oh, I need to simplify this first. That's 15 factorial. Good. Okay, so 18 and 17 and 16. That's a 6. And 15 factorial. 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. On the bottom, we've got 15 factorial times by another 3 factorial. Well, my 15 factorials are going to cancel. So I'm left with 18 times 17 times 16 over 3, 2, 1. Well, my top is 4,896. I'm cheating. I have an answer key here, which I already did the multiplication. But if you multiplied on your own, that's what you would get. On the bottom, 3, 2, 1 is just equal to 6. And then you simplify, you get 816. There's 816 ways you could pick 3 people from that room. Doesn't matter who you're picking first, second, third. You're just picking 3 people. Now, the chances of you, your best friend, and the class clown being the 3 people that were picked, well, there's 1 way. So remember, you can't have any repeating. So you can't say, oh, best friend you clown is a different option than you best friend clown. They're both the same. So there's only 1 way where you 3 are picked. If you could please right now, answer this question. So why do we use combinations instead of permutations when doing different problems? I guess the question comes down to, how are permutations different than combinations? So if you could please answer that question instead of this one. I don't like that one. How are combinations different, from permutation? That's the question I want you to answer. How are combinations different from permutations? Pause the video now, answer this question, and when you're ready to continue, hit play, and we'll go through it together. And here's what I wrote. I said permutations, the order matters, so AB is different from BA, which is 2 different permutations. So these 2 are considered 2 different permutations. Combinations, the order does not matter, so AB and BA are treated as 1 combination. So that's really the difference between a permutation and a combination. Permutations, AB and BA are different. In a combination, they're the same. If you could please, that is the homework. It says page 858, numbers 3, 6 through 10, and 27. Make sure you show all your work. This has been lesson 13.3. Thank you for watching. Bye-bye.